Codevthspan YouTube channel. In this lecture, we are going to discuss the non-static members. Any global variables declared without the static keyword is known as an non-static global members or instance members. For example, if any global members are nothing but which is used to initialize at the class area is known as an global members. If global members are declared without the static keyword, then it is known as an non-static members. Here we have three non-static members. First one would be the non-static variable, and second one is non-static initializer block or instance initializer block, and the third one is non-static methods. Firstly, we will see the non-static variable, and then one by one we will see. In order to execute the non-static member, first we need to load the members by creating an object using the new operator and constructor. Actually, what is an object? It is a block of a memory created during the runtime to load the non-static members before executing them. Here, see here. Yeah, let me take a pen. Yeah. What is an object? It is a block of a memory created during the runtime to load the non-static members before executing them. It means whenever new operator encounters, then automatically it creates a block of a memory to load all the non-static members. Int I is equals to 10. It is a non-static member to load the non-static members, and it executes from the top to bottom is known as an object. See, by using the new operator, when the new operation encounters, then automatically it creates a memory. Next, we will see the non-static variable. Any global member or any global variable declared without the static keyword is known as a non-static global variable or instance variable. For example, here int I is equals to 10, which is not declared with the static keyword, right? So it is known as a non-static variable. Here, loading process of object or instantiation. We will see how the loading process takes place. See, as I said, when new operator encounters, then it will create the object. It is a block of a memory. After that, all the non-static members will be loaded, and it will be declared with the default values. If int is equals to 0, float is equals to 0.0. After that, it executes from the top to bottom, and it always, JVM always maintains a relationship between the object and the static area. See here, what I said steps as we will see in points. New operator creates an object with reference address. See here, new operator creates an object with the reference. This reference will be stored in the obj. Load all the non-static members with default values. As I said, it first load and it will be loaded with all the default values, and it executes from the top to bottom, and reference is created which is returned. The reference which is created, that will be returned. Here we will see the syntax: class name, object reference, and the new class name. Here new P1, if P1 is a class name, we will use P1 class name constructor. Then it will be stored in address. This address will be stored in the obj, and the class name, it is nothing but primitive data. Obj is nothing but non-primitive value or object reference, and this P1 is also called as an constructor. And since the developer creates an object, we can create any number of new objects. Hence, non-static members have multiple copies of memories blocks. Here, static area is only the single copy, but here objects are creating ourselves by using the new keyword. So we can create any number of objects, any number of copies. Each object created maintain direct connection to the class static area automatically by the JVM. Here, see, it maintains the relationship between the object and the static area by JVM. And we can access any non-static members within the context area by using the object reference variable. Here what we have, object reference is obj, right? If we want to access that variable, we can access by using the object.I. This is the object reference variable. And next we will see the next slide, instance initializer block. From the right now we have discussed what are the non-static members and how the non-static members are loaded into the object and the non-static variables. Now we are going to see the instance initializer block. See, any block declared without the static keyword, then we will call it as an instance initializer block. We can create any number of instance initializer block, but it executes from the top to bottom. For example, if we have to create a block but without the static keyword, then we can call it as an instance initializer block. But it loads from automatically, it loads into the object area and it executes from the top to bottom. See here, just a minute. It is nothing but, let me take a pen. See, it is an, let me increase the size of a pen. It is nothing but static initializer block. It automatically loads into the object because it is an does not have any name, right? So we can call it as an anonymous block. It executes from the top to bottom all the operations which is present in the this instance initializer block. And we can create any number of instance initializer blocks, but it executes from the top to bottom. In order to execute instance initializer block, object should be created and loaded all the non-static members in it. To execute the instance initializer block, it should be the loaded into the object area. Non-static method. Any method declared without the static keyword is known as a non-static method. We can access non-static members by using the directly or as well as this keyword. Here, to access the non-static method in static context, we can create object and through the reference variable we can access. See, here we have the program. Object new p1, class name and the p. When the object is loaded, first it loaded with the initializes with the default value. Here we have int. So what is the its default value? 0. But it executes from the top to bottom, then 0 changes to the 10. That's it. Next, system.out.println obj.I. When it will execute, let me decrease the size. When JVM calls class loader, that it all static members will be loaded into the static area. So when main method calls, the second statement would be the object creation. So object should be the created and it returns the address which is in the obj at the rate of 100 something address it will return. Then we have system.out.println of obj.I. obj means address. In address what value we have? 10. So the output would be 10. I hope you understand non-static members. That's all for today. Thank you. Please subscribe Code with Span YouTube.